Right, please. Now we had okay. Now there was some work that you were given, and I started off with the trigonometry. On this trigonometry, we are looking at, like in this case, we want to see how to use calculators to determine given angles. How to determine, this work was given to you when we closed, but because of some comments from other learners, we wanted us to revisit it. Right? This is trigonometry here. Now, determining the size of angles using a calculator. Take note, you must always have your calculator. In order to determine the size of an angle, you have to use the inverse trigonometric function, which is arcsine, arccos, or arctan. These functions are accessed in the calculator using the shift button or second button. Do you have your calculators with you, right? Now, if you use, can you take out your calculators, please, so that we move on. Now, the pace at which you are going to be moving on this one in grade 10 is slower than the way we are going to deal with it when we'll be in grade 11. This will continue in grade 11 and 12. So now let us look at this one. When you are looking at, let us look at if we have cosine theta, which is equal to √2/2. First of all, we have cosine theta, which is equal to √2/2. Our intention, we want to find the angle theta. How do we find the angle theta? When you want to find the angle theta, you press the shift button, which is this button that we have there. And then once you press that shift button, you go on to cosine. You must have something like this, which is cosine to the power -1. Have you done so? Have you seen this? When you press shift and then cosine, it writes cosine to the power -1. This one is the arccos. So meaning to say, after so doing, you now write this number, √2/2. I want to see what you get from the screens of your calculators. You got 45 exactly, right? This is 45 degrees. It's straight away. I'm getting the point. Now, let us go on to the next one. Here, we want to show you how to use a calculator to find given angles. Now, let us look at another example. The other example that we have, if sine x is equal to 4/5, determine the size of angle x. We have got sine x is equal to 4/5. Our intention is of finding the value of x. We want to make x the subject of the formula. How can we best do that? We press shift. Now in the first one, we pressed shift and pressed sine. It pressed cosine. It gave us arc sine, arc cos. Now, if you press shift and press sine, what do you get? Arc sine. This is arc sine. From this arc sine, you now write 4/5. 4/5. I want to see what answer you get there. Please give me the answer as it is. Sorry? No, give me the whole of that. 53, 1, 1, 1, 1, 3, 0. What are the rest of the numbers?
0, 1, 0, 2, 3, 5.
0, 1, 0, 2, 3, 5. This is where I want to emphasize, because learners are used to, they just say, when they get this, they just round off. Now, here they did not specify to say, round off your answers correct to so many decimal places. But by the nature of the question, you are finding angles. Angles are, you round off to 2 decimal places. Why do you round to 2 decimal places? Because of the units that you are using. Units of degrees. 30 minutes is equal to 1 degree. So meaning to say that one is supposed to be rounded off to 2 decimal places. Since you are supposed to round to 2 decimal places, you count 1, 2. You analyze the 3rd decimal position. Now on the 3rd decimal position, what number do you have? 0. Now you throw this 0 away and then you write 53,13. Who is your mask? Right. 53,13. Are you understanding why it is like this? Right. Many learners, they make mistakes here. That is why I'm taking trouble to say, let me hammer it out so that you have a very clear understanding of it. Right? Hello? Okay. Now, with this one in mind, this is the work that you were given some time past, right? Did you encounter challenges on this exercise 1?
No, sir.
Right, if you did not encounter any challenges, because there were some learners who wanted an explanation on this. That is why I've revisited it. But now, if you are given some work and you don't write, then it becomes a problem. Did you write this exercise 1, number 3 and 4 on page 287?
Yes.
You marked them, there were no challenges. You didn't mark. Okay, let me make it this way. If you wrote and you did not mark, right, if you marked, did you get all of them correct? Right. Those that you did not get right are the ones that I want to explain, right? Now, do you have, or let us make it this way, which ones did you not get right? Okay, let us make it this way. We are in there's our WhatsApp group, right? Shame. Okay, create one. After creating that one, because in order for me to be able to plan and address some areas where you need help, because what we can do for what we cannot do for now, to say, right, I take your book, I mark there and then, that one is not allowed. But as long as you tell me that I worked this one out, I did not get it right, now I can explain. But if you don't write, the assumption would be that you are getting everything right. Why, when in actual fact you are not getting anything right? Please do yourselves justice. Right, the one that you did not get right, I think you, at the end of the lesson, you will give me the numbers so that I start addressing them tomorrow. Those who did not write, I am encouraging you to write that work, right? Great. Right, now it was exercise 1, number 3 and 4 on page 287, and number 5 on page 288. You have number 5. Right, I will address that. I will address that. So meaning to say in 10.1, it is exercise 1, number 5, which is on page 288. It is the one that you did not get right, right? Hello? Yes. Right. Now, sorry? And B. A and B, number 5, A and B. Okay. Right. Now, those who wrote and got different answers, in this class, I will address this one first and then move on. In the other class, they didn't have challenges. Now, from our, those who are connecting from home, they will also communicate, and then I will pick and address those gray areas, right? Now, let me move on to trigonometric equations. This one also was given to you, right? Yes. On trigonometric equations, let me work on those examples first. Okay. Now, here they are saying, determine the value of x. Here they want you to find the numerical value of x. So let us look at it. We've got sine 2x. Sine 2x is equal to half. We want to find the value of x. What is it that we need to do? First, what do we do? We want to make x the subject of the formula. First of all, we want to get rid of this sine. How do you get rid of sign? No. Sorry?
Oxide.
Shift sign. So if you press the second the shift button, shift and then you press sign, it will give you something like this. What do we call this one? Arc sign.
Oxide.
Arc sign, in actual fact, you are finding arc sign. So if you press shift sign and you put half, what do you get from your calculators? You got 30. Oh, so we are done, right? Because we have not found the numerical value of x, this one is 2x. So what do we need to do? We divide by 2 where? Both sides.
Both.
If you divide by 2 both sides, you now remain with x. X is equal to what? 15.
15.
This is 15 degrees. Are you following? Now remember to use correct units. 15 degrees. Don't just say 15. It's 15 degrees. Any more questions there? Are you clear? Right. You remember this work was given to you. Now, I want to recap and then see where you need help much, right?
Sir.
Let us go on to the other one.
Sir.
We have question number 2, determine the value of x. They want you to find the value of x. Since they want the value of x, but what are we given? 4 cosine. We have 4 cosine 2x plus 30 plus 1 is equal to 1. First of all, just like we were doing in simplifying, okay, Joshua.
Sir.
Hello, Joshua.
I had a question. So I had a question about
You wanted to raise something?
in grade 11 and 12, do we not use calculators?
No. Unmute yourself, Joshua. What are you, really? Very sorry. Okay, please. 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 I left, look here. It's not the first time that we are running this. I can only bar and stop those who are a nuisance. But those who are who want, I gave them leeway to unmute themselves so that they can communicate. Please. Right, look here, you seem to be knowing more than you are supposed to. Please. Well, it's unfortunate. It is only in this class. In the other class, I'm saying things, and they are here. Please. Please. Okay. Now we want to look at this one here. Now, since we've got 4 cosine 2x plus 30 plus 1, the intention is we want to make x the subject of the formula. What do? Let us identify like terms. Do we have any like terms here? Which one? This one and this one, we group them to one side. Now, if you look at this one here, 1, if you transpose to the other side, it will be 1 minus 1. What you get? You get a 0 like that. Are you getting it? Now, from that point, which is our next point? Which is the number that is next to get rid of?
4.
We look at 4. You get rid of this 4. What is this 4 doing on the left-hand side? It passes on doing what? It passes on dividing. So we divide by 4 both sides. If you divide by 4 here, you divide by 4 there, right? So ultimately what you have, you now have, because if you say 0 over 4, it gives us a 0. Now, cosine 2x plus 30 is equal to 0. The intention, let me start from here now. We are saying cosine 2 plus 30 is 2x. 2x plus 30. 2x plus 30 is equal to 0. Our intention is of making x the subject of the formula. What is it that we need to do? Sorry?
Get rid of the cos.
Cos 0. Yes.
Arc cos.
We find arc cos. Arc cos, you press shift and then on the left hand side you are going to remain with 2x plus 30 on the left hand side. On the right hand side you have, if you press shift cosine, it will be minus 1. Shift cosine, it will give you arc cos like that, right? From which you now, let us see what you are going to get from arc cos 0. What you get? You got 90, right? So from this 90 that we have, now we solve this equation. What is it that we need to do now? We transpose it to the other side, right? So 2x is equal to 90 minus 30. 90 minus 30, what is the answer? 60. So you have got 60. Is that all? What is left? We divide by 2 where? Both sides. So you divide by 2 here, you divide by 2 here. So x is equal to 30. Take note, you must use the correct units. These are degrees, right? Now, with my mouse, at times, you try to write, it becomes a very big number. But anyway, x is equal to 30. Are you following there? Any more cries there? Great. Now, for those who are at home, if you are kicked out of the lesson, because we've got a double period, if you are kicked out of the lesson, you can rejoin. We have a double lesson. Always, in fact, we are using the timetable that we used last term. That is the one that we are going to be following. So if you are kicked out, you rejoin. Right? Now let us go on to the next one. What do we have on this other example? Determine the value. We looked at sine, we looked at cosine, sine, now we're looking at tangent, right? You are supposed to find the numerical value of x. If tan x over 2 minus 1 over root 3 is equal to 0, right? What is the first thing to do? What is the first thing to do on this one? Yes? You add, right. You transpose negative 1 over root 3 to the other side. On the left-hand side, what is happening here? It is adding, right? It is subtracting. It passes on adding. Are you getting the point? Let me write it here so that what I'm talking about, you have an understanding. Now, when you transpose this one, it will be positive 1 over root 3. Are you following there? Right now, what is the next thing to do?
Get rid of the 2. 10. Get rid of 10.
We find
Remove 10.
arctan. Arctan,
Yeah.
you press shift. If you press shift and then you press the tan button, it will give you this one. It is arctan. It will write something like this: tan to the power minus 1. This is arctan, right? So the language that you use, you are saying find arctan. Are you getting me there? Right. Now we have
Yes.
we have arctan. Let us have answers from your calculators there.
30.
130. Is there anyone who got something else different? Great.
Yes.
Now, so that is the answer. Is that all? What is it that we need to do? We want to find, take note, we said we want to make x the subject of the formula. Here is x over 2. In order for us to remain with an x, you are multiplying by 2 where? Both sides. So what do you get? 60. Any more cries there? Right. This is what we have. Now, at this point, if you look at the topic that we're looking at, they are saying trigonometric equations. This is where we end with the trigonometric equations in grade 10. But in grade 11 and 12, we are going to add something here. You remember the graphs that we drew of cosine, sine, and tangent. You remember them. And then there were questions that were asked to say, what is the period? Do you still remember? Okay. Those are some of the things that we'll be dealing with. But for now, in grade 10, we end here. Any more cries there?
Mm.
Right.
Yes.
Now,
See.
it is important to note that, well, I think on this one here, this one, you will be given sine 2 theta is equal to 2 sine theta. Sine 2 theta, because others, they may make a mistake to say sine 2 theta is equal to 2 sine theta. Is that true? Really? It's not true, right? And cosine 2 theta is not equal to 2 cosine theta. Tangent 2 theta is not equal to 2 tangent theta. That one is not. Now, we will in future develop this. But for now, don't make a mistake of saying, okay, you have got cosine 2 theta. It must be 2 sine theta. No. I'm getting the point. Right. Let me go on to exercise 1, number 6, on page 288. For those who wrote, because this work was given to you, can you check and see what you wrote? If you have got challenges, I know where to start from. Let us take note of that, because this topic is very, very important. If you don't get it right, there is no way a miracle can happen in grade 11 and 12. Now, if you did not write this one, please, I'm appealing to you to write it so that when you come tomorrow, it is the first period. Now, in our first period tomorrow, that is when I will address to particular challenges that you may be having. I'm getting my point. So if you did not write, please go and write, come with it, I address it, and then we move on. Now, for those who wrote, who wrote this exercise? Right, did you mark? Did you get everything right? Okay. Any challenges? Now, look here. If you encounter challenges, if I am asking to say any challenges, the intention is of helping you. Earlier on, like first term and so on, I could say, okay, open, and then I check, and then at times I may say, I want your books, I mark and sign. But now, you have to be responsible. If I am asking, that's all I can do. If you have a challenge, now you bring the question, I explain, you get it right, you teach that one. You don't have any. Okay. Right. I think with this one, we are covered. Is there anyone here who did not try this? Great. Now, not knowing from those who are at home, if who are attending online, if you have challenges, please ask so that we can address those gray areas. Okay. Now, let me add something else on this. Because this lesson was meant to say if this lesson was meant for me to know and have an understanding of where exactly you need help on that part. Let me look at one question. Let us say if you remember the quadrants that you were given, right? On the quadrants, there are things that I want us to take note of. On the quadrants, let me do it like this. Right. How many quadrants do we have? This one is the first, second, third, and then fourth quadrant. Right? Right. Running out of time. Okay, we have a double period, don't worry. We're going to enter once more. Okay, but for now we've extended. Now, angles are measured. When we are dealing with these angles, we measure them anti-clockwise. So when we go anti-clockwise on angles, we are going positively. Are you getting the point? This one is positive. If we go clockwise, we're going negatively. Those are negative angles. Are you getting the point? Hello? Put your mask on. I know it's uncomfortable, but we have no option. Okay, now let us look at this one. I want you to take an angle here. Let us just take an angle which is between 0 and 90, any. Sorry? 35. Okay. Take out your calculators. Sine 35. Sine 35. What do you get? 0.5735. Yes, and so on and so forth. Here the intention, is it positive or negative? Positive. Now let us go on to cosine 35 and see what we get. Cosine 35 degrees, what do you get? 0.8191. Is it positive or negative? Positive. Let us go on to tangent 35. 0.720 and so on. 720. 7002 and so on and so forth. Now the intention is here we are looking at the sign. Is it positive or negative? Positive. So, okay, so we are saying all trig ratios here. What is the reciprocal of cosine of sine? Reciprocal of cosine of sine. 1 over sine. It's what? That is cosec. It's cosec. So meaning to say the reciprocal of cosine of sine, it is cosec. You remember cosec is 1 over sine. This is the reciprocal. You have forgotten, right? Now, when we talk of a reciprocal, it is 1 over. So sine and cosec, they are positive here. Now, you all realize that in the first quadrant, all trig ratios are positive. All of them, right? All of them are positive. Now, let us go on to the second quadrant. On the second quadrant, just give me any angle there. An angle that is greater than 90 but less than 180. 75. Greater than 90. Sorry? 175. So now let us try sine 175. Let us use our calculators. Sine 175 and see what we get. Sine 175. 0, 0871 71 5 1. Right. Now, is it positive or negative? Positive. Let us, sorry? Positive. Let us go on to cosine 175. Cosine 175. What did you get? Negative 0, what? 9961. So now let us look at this one. Please, if you don't behave, because others are listening at home, and if you make noise, you are disturbing them there. Please. Right. What sign do we have here? Negative. So cosine is negative. Let us go on to tangent. Let us use the same angle, tan 175. Right? Negative 0, 0.087. Right, and so on and so forth. Now, when we are looking, yes. Yes. We want to come up to that. Now, when you look at this one, you are realizing that here it is negative, and here is negative, and yes. So which one is positive? Only sine, right? In the second quadrant, it's only sine that is positive. In the first one, all of them were positive. Now, let us go on to the third quadrant. I want an angle that is greater than 180, but less than 270. 215. So let us use sine 215. Sine 215. What do you get? Negative 0, 57 35. Okay. Now, what sign do we have? Negative. Now let us go on to the other one, cosine. Cosine 215. Don't ask if this one is a 2, is a 2. Because this mouse is misbehaving here. Right. Cosine 215, what did you get? negative 0, negative 0, comma, 8, 1, 9, something, something. Let us go on to tangent. On to tangent 215. What do you get on tangent 215? 0, 700. Okay. Now let us look at this one. On this one here, which trig function is positive?
10.
Only tangent. Tangent and its reciprocal, which is cotangent. Here it is sine and cosecant, right? But let us go on to the fourth quadrant. I want an angle that is greater than 270, but less than 360. Okay, 280. Let us take, because 280 is also here. Let us say sine 280. What did you get? Negative 0, 98, 48. Okay. Now, what sign do we have? Negative. Now, let us go on to cosine 280. On cosine 280, what do you get? 0, 17, 666, 36. Okay. Now, what sign do we have here? Positive. Let's go on to tangent. Tangent 280. Tangent 280. What did you get? Negative 5. 671. 67128. Now, when you look at this one here, how is tangent here? How is tangent? Sorry, which one is positive? Cosine is positive. So, meaning to say, in the fourth quadrant, only cosine and its reciprocal are positive.